Hello students, hope you are all doing well. Welcome to another video by QuickStudy. Today we will start another topic of GCSE Physics, and our topic for today will be astrophysics. This will deal with how the planets are formed and how the stars are formed basically, and how it started and how it will end at some point. So all of this will start with the formation of the solar system. The solar system formed about 4.6 billion years ago from a giant molecular cloud of gas and dust. Gravity pulled the particles together, forming a rotating disk. The sun formed at the center as the most of the mass was under the intensive gravitational pull of the sun. The remaining material formed planets, small rocky and icy bodies, which collided and stuck together to eventually form planets, moons, and other celestial objects. So, there's a term called acceleration. The process of planets' growth is known as the acceleration. Over time, these objects grew larger due to collisions and mergers, resulting in the formation of planets. The inner planets, Mercury, Venus, Earth, and Mars, are rocky because they are formed in the hotter regions near the Sun, while lighter gases do not condense. The outer planets like Jupiter, Saturn, Uranus, and Neptune, known as gas giants, are composed of hydrogen and helium, since they formed in the cooler regions of the solar system, allowing gases to condense. So now let's learn about the life history of a star, how it is formed and how it will end. Not all the stars end at the same stage. There are basically different stages of a star forming. One of the last stages is how the sun is right now. So stars form from giant clouds of gas and dust, primarily in hydrogen in space. Gravity causes these clouds to collapse, and as the matter clumps together, it heats up, eventually forming a protostar. This is the first stage. When the core temperature reaches around 10 million degrees Celsius, nuclear fusion begins, as we have learned about fusion in the previous chapter, marking the birth of a star. The star will spend most of its life in a stable phase known as the main sequence, where it fuses hydrogen into helium. The main sequence during this phase, the outward pressure from the nuclear fusion balances the inward pull of the gravity. Our sun is currently in the main sequence stage. This is the prime form of a star. The red giant or supergiant is the next stage after the main sequence. Once the hydrogen in the core is depleted, the star begins to fuse helium and other elements, causing it to expand and cool, becoming a red giant or a red supergiant for larger stars. At some point, the sun will enter this stage, becoming all cold without giving us any heat. End of a star's life. The end of a star's life depends on its mass. Low mass stars, stars like our sun, will shed their outer layers, leaving behind a white dwarf. Over billions of years, white dwarfs will cool and fade away. High mass stars, on the other hand, stars larger than the sun, may undergo a supernova explosion, scattering their elements into space. The core remnant can either become a neutron star or, if massive enough, a black hole. For example, Betelgeuse, a red giant in the constellation Orion, is nearing its end of its life and will eventually explode as a supernova. So, other than stars, there are planets, satellites, and orbits. Let's learn about them. Planets are large celestial bodies that orbit a star and have cleared their orbit of other debris. In our solar systems, we have 8 planets, divided into terrestrial, rocky planets, and gas giants. Satellites. Satellite is an object that orbits a planet or another celestial body. Earth's moon is a natural satellite, which many man-made satellites orbit Earth for communication, weather forecasting, or scientific research. Orbits, on the other hand, are paths for the celestial bodies to follow around a larger object due to the gravity. The shape of an orbit can be elliptical, oval-shaped, or nearly circular. Planets in our solar system follow elliptical orbits around the Sun, while moons orbit the planets. Kepler's law states that the movement of planets in their orbits is described by Kepler's law of planetary motion, which explains the planets move faster when they are closer to the Sun and slower when they are further away. For example, Earth's orbit around the Sun is nearly circular, with a slight elliptical shape. It takes Earth about 365.25 days to complete one orbit, which defines a year. So, we all must have heard about the Big Bang Theory at some point. The Big Bang Theory is the prevailing explanation for the beginning of the universe, around 13.8 billion years ago. The universe was in an extremely hot and dense state and began expanding. This expansion is still ongoing, and we observe it today as galaxies moving away from each other, a phenomenon known as expanding universe. Redshift, one of the key pieces of evidence for expanding universe, is the redshift of light from the distant galaxies. We have learned about redshift in our light chapter. As galaxies move away from us, the light they emit is stretched, shifting towards the red end of the spectrum. This effect was first observed by Edwin Hubble and is now known as the Hubble's law, which states that the further away a galaxy is, the faster it is moving away from us. Dark energy is one of the recent observations that suggests that the expansion of the universe is accelerating, which scientists attribute to a mysterious force known as dark energy. For example, the Andromeda galaxy, one of our nearest neighboring galaxies, is moving towards the Milky Way, and in about 4.5 billion years, the two galaxies are expected to collide. Now we know what the beginning of the universe was, but we don't know the future of the universe. The universe began with a Big Bang, a moment when all matter and energy were concentrated in a single point. As the universe expanded, matter began to clump together, forming galaxies, stars, and planets, and so on. The cosmic microwave background radiation is the remnant heat from the Big Bang and provides strong evidence for this theory. So, what will happen in the future? The ultimate fate of the universe depends on several factors, including the amount of dark energy and dark matter. There are several possible scenarios. Big freeze is one of them. If the expansion continues indefinitely, galaxies will drift apart, stars will burn out, and the universe will become cold and dark, as there will be no stars around them. Big crunch is another explanation. If the expansion eventually reverses, the universe could collapse back in onto itself, potentially leading to another Big Bang, and everything will be destroyed in the process. The Big Rip is the last, but not so scientifically proven explanation. If dark energy continues to accelerate the expansion, it could eventually rip galaxies, stars, and even atoms apart. Everything will be ripped to shreds. For example, observation of distant supernova have shown that the universe's expansion is accelerating, supporting the theory of big freeze. It is the most logical one found so far. We have learned about the formation of solar systems, stars, planets, and orbits. We learned about how the universe started and how, at some point, it all will end. That's all for today, students. Stay with us to learn more about IGCSE Physics and other subjects as we post regularly on our channel. To learn more about our online tutoring services, do visit www.quickstudy.uk.